Alright, so today is day 14. I'm gonna show exactly what I did. It was mostly studying about reasoning under uncertainty. I'm gonna show what I did. Yesterday I studied just a few minutes and I did the first two exercises. But the main intuition on this topic is that how do you assign probabilities to events? And the way of thinking to think about it, it's how do you, for example, if you have, I think I gave this example yesterday. If you toss a coin 2 times and you get no tails, the probability of observing tails given the data that you have, if you use the maximum likelihood MLE, maximum likelihood estimator, you would say you would never see this data. Like you would never, the probability of getting tails given. If you have to predict another coin toss, you would say it's 0. It doesn't seem right because you have only 2 coin tosses. If then you have 1,000 coin tosses, the probability, the variance looks more, is less. Then we have a better estimate if we use our intuition to make a prediction. I don't know if I make myself clear. But a specific case of Bayesian inference is using the IDM model, the imprecise Dirichlet model, in which it's a special subcase because we are using a prior distribution, so we are understanding the parameter as something as a random variable, so it has a distribution by itself, and this distribution follows a Dirichlet distribution, which is a generalization of the beta distribution. And I did these 2 exercises yesterday, and for the ones of today, for example, we have this one. So we can make some sort of correction on how we estimate the probabilities, and we can say depending on how you choose your prior distribution. Alright, and let's say that you choose your prior to be, I don't know, the Jeffrey prior. Then you would have a range of the output. So you can say the probability of getting tails given an amount of coin tosses, it's between this interval. And you can compute the minimum value and the maximum value, and that's it. And then you generalize this idea even more, right? I think this one is what I said. And this one, yeah, no, and that's it. And then you generalize the idea even more because you can say, but what happens when the data itself is uncertain? Okay, we do coin tosses, but what happens if I'm not sure? If I know that the amount of tails I get it's between 1 and 2, then the output it's then so the first layer is what happens if I use sets of prior distribution, and then what happens if the data itself is uncertain, and so on and so on. You know, you are adding layers, some complexity. And yeah, this was exercise 5, which is this one, which is exactly what I said. And what else is important? I think that was, I mean, this is also a little bit important. We have a precise data set, which what happens if instead of giving the uncertainty is not only on counts but on the labels of the data itself. So I have like some fruits, and then I make a sampling of the fruits, right? And then I get a fruit, but I don't know exactly which fruit is it. So I said it's either an apple or a banana, but I'm sure it's not a tomato. And out of this, I take out like 7 different fruits, and I have some of them, the first 3 observations, that I don't know exactly which is it. So with this, I can compute like some sort of vectors that determine the range. Alright, so how many apples can I have? I mean, how many tomatoes, how many bananas? For example, in this case, how many bananas? At least 2, because I make a sample of 2 observations. And at most, I mean, in the first one, it's either apple or banana. Let's say it's a banana. In the second one is a banana or a tomato. Let's say it's a tomato. So it means that at most I have four bananas. And you do this with everyone, compute the minimum and the maximum counting. With this, we can estimate um, the lower and the upper bound, and with this we can compute actual like probabilities. And that's it. This one is about the utility, and I also did an exercise regarding generative models, which is how do you understand reality by itself. For example, I think a good example is there is people that have a disease, for example, gastritis, and then the disease causes some symptoms like stomach pain. What else? I don't know, many symptoms. So in order to understand how everything it works, you can model it like a graph, right? And say the probability of observing this, like the joint probability, it's gonna be the probability of having the disease times the probability of having a stomach pain given that you have the disease, and you make like a like a product between the parents of the nodes, and that's it. And this is very interesting because this is you're modeling how the data is generating itself. You're not computing posterior probabilities, like, because one could think about it. If I'm in the real world, I observe directly symptoms, and what I want to predict are diseases. So I'm computing the probability of having a disease given that I have the symptoms. So it's like a subset. It's like a subset of this problem. And yeah, I mean, I made a couple of exercises with this. And yeah, that was it. That's all.